Good afternoon, class. This is Unit 6 assignment. The title of this presentation is Regression Analysis using PSPP. My name is Dennis Edogun. The agenda for this presentation is as follows. Agenda 1, first hypothesis test, debt versus income. Agenda 2, second hypothesis test, savings versus income. Agenda 3, third hypothesis test, stocks versus savings. Agenda 4, main takeaways from the presentation. Agenda 5, annotated bibliography 1. Agenda 6, annotated bibliography 2. Agenda 7, annotated bibliography 3. And finally, annotated bibliography summary. Regression analysis, first hypothesis test. The following regression was conducted. No hypothesis. The regression coefficients in parentheses beta is 0. Alternative hypothesis. The regression coefficient beta is non-zero. Rejection rule. We reject the null hypothesis when P is less than alpha, where alpha is equal to 0.05. Confirmation rule. 0 is within the 97% confidence interval. A simple linear regression was conducted to determine whether we can predict an individual's debt by knowing their income. As it were, no significant regression was found. Beta value was minus 0.05. The regression R square was 0.00 with a p-value of 0.535. The test could not reject the null hypothesis because p of 0.535 is far greater than the alpha value of 0.05. Second hypothesis test. The following regression was conducted. Null hypothesis, the regression coefficient beta is 0. Alternative hypothesis, the regression coefficient is non-zero. As usual, the rejection rule. We reject the null hypothesis when P is less than alpha, where alpha is equal to 0.05. Confirmation rule. 0 will be between or within the 97% confidence interval. A simple linear regression was conducted to determine whether we can predict an individual's savings by knowing their income. Per this test, a significant regression was found with a beta value of 0.91, R square of 0.82, and a p-value of 0.00. The test rejected the null hypothesis because p-value of 0.00 is less than the alpha value of 0.05. Therefore, there was a significant regression. Third hypothesis test. The following regression was conducted. Null hypothesis, the regression coefficient beta is 0. Alternative hypothesis, the regression coefficient is non-zero. A simple linear regression was conducted to determine whether we can predict an individual's portfolio by knowing their savings. A significant regression was found again with a beta value of 0.28, R square of 0.07, and a p-value of 0.000. The test rejected the null hypothesis because p-value of 0.00 is less than the alpha value of 0.05. Now, there are some main takeaways from this regression analysis, and they are the following. One of such takeaways is the fact that PSS is a handy tool for performing a linear regression. Two significant results were obtained, that of the second and third hypothesis test. It is important to state the values of the R square, alpha, beta, and p within the parentheses as required by the APA format, which helps our readers to understand and interpret the results. The second part of this presentation will be based on the annotated bibliography. 3 bibliographies were annotated. The first one is the Edogun J.H. 2015 Chi-square Test of Independence, taken from the Handbook of Biological Statistics and retrieved from the internet at the address stated below. The article was about the utility and usefulness of the Chi-square Test of Independence when one is given 2 nominal variables and each with 2 or more possible values, and the researcher is interested in knowing whether the proportion of one variable are different for different values of the other variable. The author stressed that the Chi-square test of independence should be used when the sample size is large, thus when the size is above 1000. According to the author, this test of independence is an alternative to the G test of independence, as both tests will give approximately the same results. The Chi-square test of independence is a handy tool of determining the norm and alternative hypothesis. According to this article, the null hypothesis is that the relative proportions of one variable are independent of the second variable. That's to say, the proportions at one variable are the same for different values of the second variable. The alternative hypothesis is that the proportions at one variable are not the same for different values of the second variable. In order to reject or fail to reject the null hypothesis, however, there is need to establish the rejection rule. The rejection rule is that we reject the null hypothesis when p is less than alpha, where alpha is equal to 0.05. Annotated bibliography 1 continues. According to the author, to get a p-value, we need the number of degrees of freedom. The degrees of freedom in a test of independence are equal to number of rows minus 1 multiplied by number of columns minus 1. Thus, for a 2 by 2 table, there are 2 minus 1 multiplied by 2 minus 1, which give us 1 degree of freedom. However, the use of the PSPP made it easy to determine all these values, and that too was very handy in resolving the assignments on this course. Finally, the author observed that the Chi-square test of independence, like other tests of independence, assumes that the individual observations are independent. This article, though not for general audience, enhanced my understanding of relationship analysis with 2 nominal variables. The second article that was annotated, or annotated bibliography number 2, Mikhail M.L. 2013, the Chi-square test of independence, taken from lessons in biostatistics retrieved from the internet. In this article, the author argued that the Chi-square statistic is a non-parametric, thus distribution-free tool designed to analyze group differences when the dependent variable is measured at a nominal level. Like all non-parametric statistics, the Chi-square is robust with respect to the distribution of the data. It does not require equality of variances among the study groups or homoscedasticity in the data. I hope I got that pronunciation right. It permits evaluation of both dichotomous independent variables and of multiple group studies. The author emphasized that unlike many other non-parametric and some parametric statistics, the calculation needed to compute the chi-square provide considerable information about how each of the groups perform in the study. This richness of detail allows the researcher to understand the results and thus to derive more detailed information from the statistic than from many others. The author noted further that the chi-square is a significance statistic and should be followed with a strength statistic. The Kramer's V is the most common strength test used to test the data when a significant chi-square result has been obtained. That's to say that when we reject the null hypothesis per the rejection rule, we should proceed further to obtain the Kramer's V value. The Kramer's V value of 1.000, as was the case in Unit 5 assignment, indicates a perfectly symmetric relationship between the two variables, which was in this case non-Cas and Likert comfort. Continuation of this review. The author noted that the chi-square test of independence has some advantages and disadvantages. Advantages of the chi-square include its robustness with respect to distribution of the data, its ease of computation, the detailed information that can be derived from the test, its use in studies for which parametric assumption cannot be met, and its flexibility in handling data from both two group and multiple group studies. Disadvantages include its sample size requirement, difficulty of interpretation when there are large numbers of categories, 20 or more, in the independent or dependent variables, and tendency of the Kramer's V to produce relative low correlation measures even for highly significant results. This article taught a step-by-step procedure to calculate the chi-square without the use of any software. This knowledge was very instrumental in my understanding of the course and how to perform a relationship test between two variables. The third annotated bibliography, Lane, DM, no date, confidence interval on the mean, retrieved from the internet. In this article, the author taught the utility of the confidence interval on the mean, noting that when you compute a confidence interval on the mean, you compute the mean of the sample in order to estimate the mean of the population. Thus, if the population mean is already known, there will be no need to compute the confidence interval. The author noted that in order to better understand the concept, he proposed a procedure of working backwards and began by assuming the characteristics of the population. Thereafter, he showed how sample data can be used to construct a confidence interval. According to the author, confidence intervals for means are intervals constructed using a procedure that will contain the population mean a specified proportion of the time, typically either 95% or 99% of the time. These intervals are referred to as 95% and 99% confidence intervals respectively. He taught how to use the t-distribution rather than the normal distribution when the variance is not known and has to be estimated from sample data. When the sample size is large, say 100 or above, the t-distribution is very similar to the standard normal distribution. However, with smaller sample sizes, the t-distribution is leptochotic, which means it has relatively more scores in its tails than does the normal distribution. As a result, you can extend further from the mean to contain a given proportion of the area. Recall that with a normal distribution, 95% of the distribution is within 1.96 standard deviations from the mean. Using the t-distribution, if you have a sample size of only 5.95% of the area is within 2.78 standard deviation of the mean. Therefore, the standard deviation of the mean will be multiplied by 2.78 rather than 1.96. The values of t to be used in the confidence interval can be looked up in the table of the t-distribution. Below are the summaries from the 3 articles that were annotated. These annotated bibliographies were very useful and aided my learning experience as they provided the needed knowledge in the area of statistical data analysis. For instance, Edogun 2015 observed that the chi-square test of independence, like other tests of independence, assumed that the individual observations are independent. This article, though not for general audience, enhanced my understanding of relationship analysis between two variables. Similarly, McHale 2013 noted that the chi-square is a significant statistic and should be followed with a strength statistic. The Kramer's V is the most common strength test used to test the data when a significant chi-square result has been obtained. That's to say that when we reject the null hypothesis per the rejection rule, we should proceed further to obtain the Kramer's V value. The Kramer's V value of 1.000, as was the case in the Unit 5's assignment, indicates a perfectly symmetric relationship between the two variables. Finally, Lane notates argue that confidence interval for means are intervals constructed using a procedure that will contain the population mean a specified proportion of the time, typically either 95% or 99% of the time. These intervals are referred to as 95% and 99% confidence interval respectively. Knowledge of the confidence interval is very useful in regression analysis. Thank you very much for watching. This is the end of my presentation. If there are any questions to be asked, please ask at this time. And if there are no questions, thank you very much for your time and do have a pleasant afternoon. Bye.